Welcome to the weekly Pacent test video. On this next screen, you're going to see all of the start times of the problems, so you can just fast forward to the problems that you want to look at. All right, here we come with this week's video.
Alrighty, so we're going to look at the week 12 test. We're going to go through each of the answers. Remember, you can replay this back as often as you need it so that you will have it as a reference. Problem number 1, which is the new section, direct variations from a graph. So they give you this information. Jason graphed the total number of miles he ran for the total number of days he worked out. Number of miles was the y, number of days was the x. The graph was a straight line that passed through the origin and the points 3, 6. So the first thing I did on my paper was I reminded myself of the slope formula. Slope equals y divided by x. I took out the x and the y values, so x equals 3 and y equals 6 in that point 3, 6. And I underlined the origin. That tells me that the line passes through 0. Now I'm ready to answer the 4 questions. Remember, I'm only circling the ones that are true. So question A, slope of the line is 1/2. That's not true. The slope of the line, since it's y divided by x, is 6 divided by 3 or 2. So the slope is 2. Don't circle A. Letter B, the y-intercept of the line is 3. That's also false. The y-intercept of the line is 0, 0 because the line goes through the origin. So I didn't circle B. I did circle C. Now you might have just circled the letter and that's fine. C is correct because Jason ran 2 miles per day. That's the statement. And what we know is that the slope equals how much he runs per day. So since the slope was 2, the corrected slope was 2, right there, 2, we know that he ran 2 miles per day. And then finally, after 5 days, Jason ran 10 miles. Well, we know he's running 2 miles per day times 5 days. Yes, that equals 10 miles. Okay, remember, if you have questions, you can go back and review this. You can certainly ask me later. Let's move down to problem number 2. Sarah's baking brownies for the bake sale. This is a problem with ratios. She needs a 1/4 cup of flour, or a 1/4 cup of sugar, for 3/4 of a batch of brownies. A, write a proportion you could use to find how many cups of sugar is needed for 1 batch of brownies. So our ratio is sugar to batches. How much sugar to how much of a batch? The unknown, let me circle the unknown here. How many cups of sugar? Should be are needed, by the way. This was written by a math teacher, apparently. How many cups of sugar? That is the unknown. That's the x. So we set up the original ratio. 1/4 to 3/4 is x to 1, because we're making 1 batch now. And then for part B, we solve that. We get 1/3 of a cup. Here's how we did it. I changed my fractions into decimals. 1/4 is the same. 1/4 is the same as 0.25. And 3/4 is the same as 0.75. I cross-multiplied 0.25 times 1, 0.75 times x. 0.25 times 1 is 0.25. 0.75 times x is 0.75x. We divide by the coefficient. We know we've divided by the right thing because we get a big 1 right there. We get x is equal to the 0.25 divided by the 0.75, which is 0.3 repeating, and that is the fraction 1/3. You could have either the answer 0.3, you write that over here, so the answer is 1/3 of a cup, or 0.3 of a cup. So if you had either of those, they're correct. All right, let us move to problem number 3. So for problem number 3, and I need to adjust this screen. Let's see if we can get this down a little bit so it covers our whole problem. There we go. Problem number 3. The number of times the cricket chirp varies directly with the temperature outside. Yes, we know. We've talked about this several times. The cricket chirp is the dependent. The temperature is the independent. The temperature controls the chirping. The crickets don't control the temperature. So the first part, find the constant of variation. Constant of variation is always dependent divided by independent. So 21 divided by 7, or 39 divided by 13, or 45 divided by 15. If we do any of those, you'll see we get 3. So that's our constant of variation. Number of times the cricket chirps in 25 seconds is C. T is temperature in Celsius. Here's our formula. It says write an equation you could use to find the number of times the cricket chirps in 25 seconds. Well, the chirps equal 3 times the temperature. And we saw that in our table. 3 times 7, 21. 3 times 9, 27. 3 times 11, 33, and so on. All right. Again, write whatever notes you need to make. Pause this so you can take good notes. Listen to it again if you need to. Bring me questions. And we are on to number 4. So for problem number 4, we are dealing with a ratio problem. It tells us that Jackson painted the exterior of his house using 65 gallons of paint. That's the total. He mixed 26 gallons of red paint with 39 gallons of blue paint to make the purple color he wanted. Purple house. Wow. I'm not sure I'd want that in my neighborhood. Anyway, purple house. So, and you know that if you put the 26 and the 39 together, if you take 26 plus 39, I can see my work is off the screen a bit. That should be where you can all see it. 26 plus 39 will give you the 65. So it's either red or blue in that color. So he decides to paint the interior of his house with the same color. If he needs 20 gallons to cover all the walls, how many gallons of red does he need? Well, we know our ratio was 26 red to 65 total. How many gallons of red paint? That is our X. That's the unknown amount. Let me try that line again. How many gallons of red paint? All right, so we cross multiply. 26 times 20 right here, 26 times 20. X times 65 right there. 26 times 20 is 520. X times 65 is 65x. Divide everything by 65. That's the coefficient. That gives us our big one right there. And we get X equals 8. 8 gallons of red paint. All right, 8 gallons of red paint. Now, part B, how many gallons of blue paint does he need? Well, same idea. The original ratio, 39 to 65, equals X to 20. Cross multiply, 39 times 20, 65 times X. We get 780 equals 65X. Divide by 65. That is the coefficient. And we get 12. 12 gallons of blue paint. Okay, again, pause if you need to make notes. Make sure you're understanding it before you move on. Here is the last problem. The last problem is a little bit bigger, a little more space. Let's see if this will let me. Well, it doesn't really let me change the size once we get started, so I'm going to leave it. I'm going to leave it down here. Might be a little bit that you don't get to see, but I can rewrite it for you. All right. Brooks painting used the following amount of primer and paint for each job site this week. So we know primer, 5 gallons, paint was 2.5. Primer 10 gallons, paint was 7.5. Primer 15 gallons, paint was 15. So first question they ask is graph these values at the right. Here's everything graphed. Here's the 25 37.5 on the graph. This very first one is the 5, 2.5, all your graphed points. Is this a proportional relationship? And the answer is no, it's not proportional. This is not a straight line, so that tells us it's not proportional. Also, the graphed amounts do not end up being proportional, and I had put them down here below where you can now see. So let me bring them up. You divide the 25 by 5, you get a half. You divide the 15 by 15, you get 1. You divide the 25 by 4, bring it up as this last one here, you get 5 over 4. Those are not equal to one another. And since these are not equal to one another, it's not a proportional relationship. All right, so there you go. Oh, I always say that, and then one of you will say, wait, you forgot the problem at the bottom. And yes, I forgot the problem at the bottom. So let's go to the problem at the bottom. And the answer to the problem at the bottom, I'm going to bring this down. And the answer to the problem at the bottom is yes, it is proportional. If you look at any of those, the 7 divided by the 1, the 14 by the 2, the 21 by the 3, or the 28 by the 4, you will get 7. If you graphed those, they would be a straight line and they would go through 0. All right, that's your test. Do whatever you need to do to help yourself with the problems you got wrong. That might include going online, looking at some resources. That might include finding somebody to help tutor you. That might include asking me some questions. Whatever it includes, do those things so you can be more successful.